Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.4, and we are going to start with question number 4A. Okay, so they've basically they've given us two equations, and they've told us to find the set of values for x for which both of these equations are going to be satisfied. So let me just solve this first, both of these equations, and then I'll explain you why they're really important to solve simultaneously. Okay, so x squared minus 11x plus 24 is lesser than 0, and 2x plus 3 is lesser than 13. Okay, if we would solve this quadratic equation, we would take some factors. I'm only going to solve this one with you. The rest I'm going to use my calculator. The 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6, 3 1s are 3. And we have to make up 11. So 2 2s are 4, 4 2s are 8, 9, 10, 11. So it's going to be x squared minus 8x minus 3x plus 24 is lesser than 0. And for the other one, it's a simple straight line equation. So it's going to be 2x is lesser than 13 minus 3 is 10. Again, simplify this, x multiplied by x minus 8 minus 3 multiplied by x minus 8 is lesser than 0. And for the other one, we have x is lesser than 10 divided by 2 is 5. And similarly, what we have for this one is x is equals to positive 8 and x is equals to positive 3. So I recommend to all of you to whenever you make whenever you solve these type of questions, make a really rough graph with you. So if we make a rough graph, we assign the points 3 and we take this to be 8. It's not supposed to be accurate, only to just give you a visualization. And if we would make a quadratic parabola from the point 3 and 8, okay, and then we would just assign the 0.5 here. So this was a quadratic equation and this was a straight line equation, so we just make a straight line at 5. Now basically what this question asks us, and when it gives us two equations, it's asking us to give us this set of values for x for which both of these equations are going to be satisfied. So for example, x is going to be satisfied when it's between 3 and 8. It's going to be lesser than 0 between the points 3 and 8. Okay, but x is also going to be lesser than 0 when it's lesser than 5. However, if we pass this point at 5, okay, if we pass 5, for example, we take the point 6, okay, we say this point is okay, it's going to accept the values between 3 and 8. So it's acceptable for the first equation. However, if we take the point 6 for the second equation, which is 2x plus 3 is lesser than 13, we say that it's not going to be equal because x is actually lesser than 5. So it's not going to be part of the equation. So we have to give the set of values for x in which we are going to satisfy both of the equations given in the question. So again, it's going to be simple. As we have drawn a graph, we are going to say that x is lesser than 5. So whatever values are above 5, we are going to ignore them, or you can say cut them down. So what we have is 3 till 5 are the acceptable values. And that's what we are going to say. The answer is x is greater than 3 and lesser than 5. If you do not understand what I explained right now, try to watch this again, and even if you don't understand that again, see the next part. I'll try to explain it more clearly then. So for part B, let me just erase this real quick. Okay, for part B, we have again two equations, x squared minus 4x is lesser than and equals to 12. And for the other one, we have 4x minus 3 is greater than 1. Okay, so if you just solve this quadratic equation, x squared minus 4x minus 12 is lesser than equals to 0. And for the other one, we have 4x is greater than negative 3 will become positive 4 here. So 1 plus 4, negative 3 will become positive 3 here, and it's going to become 4. Again, now what I'm going to do is use my calculator here to solve this quadratic equation. I hope by now you do know how to solve quadratic equations. And if you don't, just use a calculator. It is much more easier. So x equals to negative 2 and x is equals to positive 6. Okay, so these are the 2 points of x which these are the 2 points at which the x-axis is being crossed, meaning the y is 0. And for the other one, we have 4 divided by 4 is 1. So x is lesser than 1. X is greater than 1. Okay, so if we again draw a really rough graph and just approximation. So we take this point to be negative 2, we take this point to be 1, and this point to be 6. So our first quadratic parabola is going from negative 2 till 6. And what they've told us, a straight line is going at x is equals to 1. And what they're saying is that x is supposed to be greater than 1. Okay. So again, as in the previous question, we have to satisfy both of these equations. So negative 2 till 6 is going to, the first equation is going to be accepted, but not the second equation, because negative 2 is actually lesser than 1, and they have asked us that x should be greater than 1. So what we are going to do is we are going to take this up, we're going to ignore the values which are before 1. So when x is lesser than 1, we are going to ignore it, and what they've told us, x is greater than 1. So whatever value is going to be acceptable for the second equation, which is greater than 1, is going to be taken in consideration. So from 1 till 6 are the values we can take in consideration. So x is actually greater than 1, but x is lesser than 6. By the way, it's going to be lesser than equals to 6, because at this point in the graph, the quadratic equation tells us the values which are equals to 0 are also to be taken. So it's going to be lesser than equals to 6 here. Okay, so for part C, we have x multiplied by 2x minus 1 is lesser than 1. And for the other one, again, we have a straight line equation, 7 minus 2x is lesser than 6. Okay, so what we're going to do is, first of all, open this bracket up. So 2x squared minus x is lesser than 1. And negative 2x is lesser than 6 minus 7. So again, 2x squared minus x minus 1 is lesser than 0, and negative 2x is lesser than negative 1. And basically, again, I hope you guys remember the rule that whenever we cut the negative on both sides, we change the side of the inequality. So it's less, 2x is lesser than 1 at this point, but it's now going to be greater than 1. Because we have divided both the sides by negative 1. So yes, negative 1 actually. So it's going to further simplify into x is greater than positive 1 upon 2. And for the other one, I'm again going to use my calculator here. So we have got x is, yes, so it's going to be x is equals to negative 0.5 and 1. Okay. Wait a second, let me just check if it is, it's negative 0.5 plus 3. Yes, it's negative 1.5. 0.5. Okay, so again, if we just draw a graph here, we have got -1/2 here, we have got 1 here, we have got +1/2 here. So our straight line is going through the point +1/2, and my bad, it's we also have a 1 here. Sorry. So our quadratic parabola is going to go from the point -0.5 up till 1. And again, it's just similar to the previous questions we have solved. We have to tell the um, values for x for which both of these equations are going to be satisfied. So for the second one, this is a clear message that we do not take any values which are lesser than 1/2, because x is greater than 1/2. So whatever values are behind 1/2, we are going to cancel them out. Sorry if I'm being a bit too rough, but just to make you guys clear. So what we're going to get is x is actually greater than +1/2, but it is lesser than 1, which is the last value accepted for the quadratic equation. Okay, so this is the answer. For the other part, okay, for part D, we have two quadratic equations this time. X² minus 3x minus 10 is lesser than 0, and x² minus 10x plus 21. X² minus 10x plus 21 is lesser than 0. Okay, so again, just solve this quadratic equation real quick. I'm going to get my values. X is equals to 5 and -2. And for the other one, x is equals to 3 and 7. Okay, so again, make a graph here. Plot the two parabolas for the quadratic equation. We have got one from -2, something like here, up till 5. There's one parabola here, and the other one is from +3 up till 7. Okay. Now, when it comes to parabola, this gets a little bit tricky. So what I'm going to use, I'm going to use my color markers so that it's going to be easy for you to understand. So basically what happens when they are asking us the set of values for x for which both of these two quadratic equations are going to be satisfied. So it's going to be the point where both of them are going to exist. So for example, if we see what they've asked us are the values which are lesser than 0. So we are going to see for the first parabola, we see the shaded area. Okay, we shade the area for the first parabola which is lesser than 0. It's going to be this whole area. Okay, and for the second one, let me just choose a different color here. Okay. For the second one, we are going to mark the values which are going to be acceptable. So it's going to go like this. Okay, so now if you can see, the point between 3 and 5 are the point where both of these are going to exist, meaning both of their values are going to intersect. So that's exactly what we want. The points where both of these equations are going to exist is the point they have asked us in the question actually. So we are going to say that that x is actually greater than 3, but x is lesser than 5. And that's our answer. Okay, for part E, which is the last part. Let me just erase this one. And we have got some space. Second. Okay, for part E, we have got x² plus x minus 2 is greater than 0, and x squared minus 2x minus 3 is lesser than equals to 0. Sorry, is greater than equals to 0. My bad. So again, what I'm going to do is use my calculator to find the quadratic equations. In fact, what I'm going to do is I'm going to solve this. So we have got x here. We take this as the common x plus 2. Wait a second. So we take this x squared plus 2x minus x, make the factors. Minus 2 is lesser than 0, sorry, greater than 0. Okay. And for the other one, we have got, wait a second, please. Okay. So for the other one, we have x squared minus 2x minus 3. If we make the factors for negative 2, we are going to get x squared minus 3x plus x, sorry, plus x minus 3 is greater than equals to 0. Now what we're going to do is take x plus 2 minus 1 x plus 2, which is greater than 0. And so for the other one, x squared minus 3x, wait a second, x as the common x minus 3 plus 1 as the common x minus 3 is greater than equals to 0. Okay, so what we're going to do next is take out these values. So x minus 1, x plus 2 is lesser than 0. X plus 1, x minus 3 is greater than and equals to 0. Okay, so again, we have got two values for x for which y is equals to 0. So x equals to 1 and negative 2. And for the other one, x is equals to negative 1 and positive 3. Now again, as usual, we are going to draw a really rough graph to visualize. And what we are going to say is there's a parabola going from negative 2 up till 1. It's going to be second. It's going to come from here all the way up there. And the other parabola is going from the point negative 1 all the way till 3. So here it goes. Let me just make it. Good. So again, I'm going to use a different colored marker to show the points which are going to be accepted. So now what they've asked us are the values which are greater than 0 for the set of values. So if we see what they're literally asking us are the values which is going to be greater than 0, meaning the values which are above the x-axis. So for the first graph, it's going to go up from here all the way up till infinity. And same for the other point. Okay. And for the second graph, it's going to be a similar one. From one point, it's going up till infinity, and the other is going up till infinity. Okay. So basically, whatever value, except the values which are below the x-axis, are going to be accepted because they're going to be greater than 0. So we can say for any quadratic equation parabola, any value which is above the x-axis is the value which is greater than 0. That's basically what they mean. Okay. So it's going to be tricky to understand this. So please do listen carefully. So the fact is, whenever we talk about intersecting values which are greater than 0, we take the farthest point, meaning negative 2 and 3. Why? Because the thing is, if we take, for example, let me just take that the point negative 1, or in fact, the point 1 itself. We say this is the point 1, and this is the point of the graph. Now, for the equation, which is x is negative 1 till 3, this is going to be acceptable. It's going to be greater than 0. Okay. However, for the other graph, at the point 1, it is below the x-axis and is at some point what we do not know. But it's below the x-axis. Its value for y is negative, and it's lesser than 0. However, we want the values to be greater than 0. And that's basically it. when we take the farthest point, we say that it's going to be accepting the values which is for the um, parabola which is on the outside, but it's also going to accept the values for the parabola which is on the inside, because it's already passed the value of 0 when this one has passed. Okay, so what I mean is, whenever we take the values for two intersecting equations which are greater than 0, we say the farthest points are going to be our answer, because they are going to accept the values of not only their graph but also the graph which is inside them. Okay, so what we are going to say is x is actually greater than um what is it here? So x is sorry, is going to be x is lesser than -2, but x is greater than and equals to +3. We have add and equals to because for the value which we have got +3, it also set the value which is equals to 0. So that's it. And this is the answer for part E. I hope it is clear to you. If it's not clear, please do ask in the comments what you're not clear about, and I'll try my best to solve it. Okay, so proceeding on to question number 5. So it's going to be a little bit of a tricky question, question number 5. So just listen carefully. For question number 5, part A, we have x squared plus 2x minus 2 in a modulus, and we say it is going to be lesser than 13. Okay. Now the thing is, whenever we open a modulus, okay, let me just explain you with an example. So whenever we are going to use a modulus, for example, we have the, oops, it's too light. We use this purple. Whenever we use a modulus, for example, we have the equation 2x plus 3 in a modulus is greater than 13. Okay. So whenever we open a modulus in an inequality, what we do is we say 2x plus 3 is greater than 13. Okay. We copy the first equation as it is. However, we add another equation, or 2x plus 3 is lesser than -13. There's going to be two changes in the second equation. And what are the two changes going to be? What are the two changes that are going to take place? So they are that the side of the inequality, the face of the inequality is going to switch. So right now it was greater than, but now it's going to be lesser than. And the other change is that we multiply the value on the other side by negative. Okay, so these are the two changes. The first equation we copy as it is, but the second one we apply these two changes. We multiply the other side by negative, and we switch the side of our inequality. Okay, so now let me use my marker. Okay, so let me just erase this real quick. Now we are going to apply the rules we just understood right now in here also. So x squared plus 2x minus 2 is lesser than 13. We copy the first equation as it is. However, for the second equation, we say x squared plus 2x minus 2 is greater than -13. Okay. Now just solve this real quick. X squared plus 2x minus 2 minus 13 is lesser than 0, or x squared plus 2x minus 2 plus 13 is lesser than 0. Okay. So we are going to get x squared plus 2x minus 13, 14, 15, -15 is lesser than 0, or x squared plus 2x minus 2 plus 13 is going to be positive 11 is greater than 0. Okay, so now what I'm going to do is use my calculator here. So I'm going to get x is equals to -5 plus 3 for this, and sorry, -5 and +3 for this. And for the other one, I'm going to get iota values for x. So can say this is not applicable here because iota values are not to be taken in O-level addition in mathematics. It's not in the syllabus for now. So whenever we get a iota value in a calculator or whatever it is, we just ignore the value for now. Okay, so 5a, -5 and +3, we have the values. And if we just draw the graph here, they've asked us the values which are +3, sorry, -5 and +3. So it's going to come from here all the way up till here. And what they've asked us are the values which are lesser than 0. Okay, so the value which is lesser than 0 is obviously the value which is below the x-axis. So the points between -5 till +3 are going to be acceptable for the question. So we can say that x is actually greater than -5, but it's lesser than 3. And that's the answer for question number 5, part A. Okay, so for part B, what we have is a similar equation. We are again going to open this up. X squared minus 8x plus 6 is lesser than 6. We are going to copy the first equation as it is. However, for the second equation, we are going to say x squared minus 8x plus 6 is greater than -6. Okay, so if we just solve this up, for the first part, we have got x, because these are going to cancel. X squared minus 8x is lesser than 0. And for the other one, we have x squared minus 8x plus 12 is greater than 0. The first one is going to be simple. X as common, x minus 8 is lesser than 0. And we have got two values for x equals to 0 and 8. For the other one, we are going to take this up and we are going to say that we have two values for x in the calculator. X equals to 2 and x equals to +4. Now again, a really rough graph for visualization. And I would recommend, especially in this question, please do use a graph because it's going to make your life easier. So from here, 0 till 8, something like that. It's just an approximation. And the other one is going from +2 up till 4, something like that. So now basically what they're asking us in the first equation is the values which are lesser than 0. So for the graph which is from 0 till 8, they are asking us the values which are lesser than 0, which are going to be all the way till here. However, for the second graph, they have asked us the values which are greater than 0. So that would mean the values which are above the x-axis. And these lines are going up till infinity. So we have to tell the values for which the first graph, which is going from 0 till 8, is lesser than 0. And at the same time, the second graph, which is between 2 till 4, is greater than 0. So when are those points intersecting? So from 0 till 2, if we see, our first graph is lesser than 0. Okay, yes, it is. And similarly, from 0 till 2, the second equation is greater than 0, as we can see. However, if you would pick the point, for example, 3, well, at the point 3, the first graph is lesser than 0. It's following the conditions given in the question. However, the second graph is also lesser than 0 at this point. However, what the question asked is the point which is greater than 0. So the point 3 is not going to be applicable in our equation because it's not satisfying both of our requirements in the question. So what we can say is when x is greater than 0 but lesser than 2, it's going to have the first graph being lesser than 0 and the second graph being above 0. And then from 4 till 8, okay, so we are going to get two set of values for this. So x is greater than 4 but lesser than 8. It's going to have the what you can say, it is going to have the range which is lesser than 0, and the values for x which is above the x-axis and which is going to satisfy the second equation. So again, I'm repeating, we have to tell the values for x for which both of these equations are going to be satisfied. I know it's a little bit tricky. If you still don't understand what I mean, ask in the comments. I'll try my best to answer your questions. Okay, so let me just erase this part. Okay, for part C, what we have got, x squared minus 6x plus 4 in a modulus is going to be lesser than 4. So again, the same technique, x squared minus 6x plus 4 is going to be lesser than 4. We are going to write this as it is, or x squared minus 6x plus 4 is actually greater than -4. We're doing two things. We are flipping the side of the inequality and we are multiplying negative with the second value on the other side. Okay, for this is for part C. Let's just continue this. So we are going to get x squared minus 6x plus 4, -4 is going to cut down, is lesser than 0, or x squared minus 6x plus 8 is greater than 0. We are going to get x as the common, x minus 6 is lesser than 0, or x squared minus 4x plus minus 2x plus 8 is greater than 0, and we are going to get x as the common, x minus 4 here, minus 2 as the common, x plus x minus 4 is lesser than 0. So x is equals to +2 and x equals to +4. We have two sets of values for x equals to 0 and x equals to 6 here too. So again, a really rough graph just for visualization. You're going to draw a parabola from the point 0 all the way up to 6, and another point from 2 till 4. So it's going to come up here till like this. However, there's some difference in this. For the first equation, they are asked us the values which are lesser than 0. So those values are going to be somewhere like here. However, for the second equation, they have asked us the values which are greater than 0, meaning which are above the x-axis. So it's going to be something like here. And again, we are going to follow or we are going to give the set of values for x for which both of these equations are going to be satisfied along with their conditions. So as in the previous question, when x is greater than 0 but lesser than 2, it's going to satisfy both of the equations. How? From 0 till 2, the first equation is lesser than 0. We can see that. And from 0 till 2, the second equation is greater than 0, as we can see. And that's the point of visualization of a graph, because it's going to make it easier for you to know what's asked in the question and what you have to answer. And that's why it's not required in the question, but it's just here in the rough draft so that you can get an accurate answer. And similarly for the other one, when x is greater than 4 and lesser than 6, it's going to satisfy the values for which the first equation is lesser than 0, as we can see here, and the second equation is greater than 0. Again, because when we take the point +3, for example, it's going to satisfy the first equation because it's going to be lesser than 0 at that point. But we do not satisfy the second equation, which asks us to be greater than 0 at the point 3. So we can say that it's not applicable to add 3, or we can say we cannot add 3 as the set of values for x for which both of these equations are going to be satisfied. Because if we add 3, only one equation is satisfied along with its condition. So when we add these two set of values, our conditions are going to be accepted. And so is our answer. So that's it. And this is for question number 5. And the last thing we are going to do for today is question number 6, which is our challenge question. It's basically really easy if you know the concept behind it. So what we're going to do is, first of all, write down this equation. So question number 6, 4 upon 3x squared minus 2x minus 8 is lesser than 0. Okay, so what we are going to do is just in the denominator, solve this equation. By the way, most of the students, what they do is this mistake that they solve this by, and let me just make this red so that you know what I'm going to do right now is going to be wrong. So what they do is reciprocate this. So 3x squared minus 2x minus 8 is divided by 4 is greater than 0. And then they multiply here. So then we have the simplified equation 3x squared minus 2x minus 8 is greater than 0. We cancel out 4 with the 0. But this thing we do is wrong. It's completely wrong. The method I'm going to do now is going to be the correct one. Let me use my correcting. Okay, so what we do is basically solve this 3x squared minus 2x minus 8 as in the denominator. So I'm going to use my calculator for now. So I'm going to get two values for x equals to 2 and x equals to negative 4 upon 3. And again, if we get these two values, what that means is we are actually getting 4 divided by x minus 2 multiplied by x plus 4 upon 3, okay, is lesser than 0. That's basically what it means. So if you would put that into the calculator, we would get these two values as the answer. And basically, we know this is a positive value, okay? The positive 4, we know it's a positive value, so we know this inner denominator should be a negative value, okay? And when that's a negative value, we know that it's going to be lesser than 0. So what we do is we take this up, we say that x minus 2 and x multiplied by x plus 4 upon 3 is going to be lesser than 0 because it should have a negative value. And we, for now, we just ignore the value 4. Why is that? Because it's not necessary right now. They've asked us the range of values for x for which this is going to be accepted. So right now, just ignore the 4 here and just solve this up. So we are going to get x equals to 2 and x equals to negative 4 upon 3. And again, if we just draw a graph for visualization, we would get a parabola something like negative 4 upon 3 is 1.333 something. And up till here. So if we go and use this parabola, we are asked the values which are lesser than 0. So these are the values which are lesser than 0. Any value which is between negative 4 upon 3 up till 2 is going to be lesser than 0. So what we are going to say that x is actually greater than negative 4 upon 3, but it's lesser than 2. And that's question number 6, our challenge question for this exercise. And that's it. This is for exercise 2.4. I'll meet you in the next lecture with our next exercise really soon, I hope. So this is it for today. Thank you.